moment of force. Okay. The definition of moment of force, okay, is the product of force and perpendicular distance from the pivot. Okay, for example, this is the pivot and this is the door. I am looking at the door from the top. Okay, suppose if I want to open the door and if I'm applying force in this direction, the distance between the axis of rotation, that is the pivot, and this is the point of application, this distance is d. In this case, the moment of force is going to be force multiplied by, okay, the angle between these both is 90 degrees. So force multiplied by this perpendicular distance, this is going to be the moment of force. Okay. Next part is moment of force and equilibrium. I'm considering over here, say for example, a meter rule is there. Okay, this is the support, that is going to be the pivot. So it can be rotated in this direction, that is going to be the clockwise direction. It can be rotated in the other direction, that is going to be the anti-clockwise direction. Okay, suppose if I'm considering here that some mass over here is kept, because of gravity it is going to pull it in the downward direction. This is going to be giving you the anti-clockwise moment. Of course, that is going to be the force multiplied by the distance from the pivot. And similarly here, the clockwise moment will be given by the second weight of mass that is kept on the right hand side. This force I am going to consider it as F2, and the distance between the pivot and the center of this is going to be D2. Okay. Now in the condition of equilibrium, equilibrium means when both of these forces balance each other. I'm going to have here total anti-clockwise moment will be equal to total clockwise moment. So that's going to be equal to F1 into D1. This will be equal to F2 into D2. Okay, I'll just consider one simple example. Okay, so the example for this, this is the meter rule. This is the 0 mark. This is the 50 centimeter mark. This is there at the mark of 10 centimeters. And this mass is say 20 grams. Okay. Another mass is there, which is kept on the right hand side. Is kept at the mark of say 85 centimeters. And I'm supposed to find this mass. Now, how much is D1 over here?
10.
No, it won't be 10. It will be 40 centimeters. Because the 0 marking is over here and this distance is 10. So this distance will be how much?
Yeah, 40.
Correct? So this distance D1 is 40 centimeters. This distance D2 is how much?
35.
Okay, it will be 35 centimeters. Here the mass is 20 grams. Here the mass is unknown. Okay. So now here anti-clockwise moment in the condition of equilibrium will be equal to the clockwise moment. Of course, this is mass. We can convert it into force by multiplying into G. that is gravitational acceleration. But since both of them will be present on both the sides, that is G will be present on both the sides, so I can just ignore that. You can cancel it out from both the sides. Okay, so here I'm going to get here M1 into D1. This is going to be equal to M2 multiplied by D2. Okay, so this is M1, which is 20 grams, multiplied by here D1, this is 40 centimeters. This is equal to, this M2 is M, which is unknown, multiplied by here the distance is 35 centimeters. You can simply work this out. Okay, this is going to become 800 upon 35.
What?
Okay, so this is your mass. Yeah, what will be the first statement?
The moment of a force about a point is distance multiplied by mass.
Okay, not mass, it will be force, basically.
Yeah. Will be the stone to where the 40 Newton is there.
Yeah, so how much is the distance?
1.20 meters.
Yeah, 1.2 meters.
Yeah.
Yeah, can you solve the third part? How will you get the clockwise moment?
1. So you do 1.20 into 40 is equal to 0.20 into f2, no?
No, we just have to find the clockwise moment. See, the clockwise moment is going to be in this direction.
Yeah.
Correct? Now, what are the clockwise moments? First of all, here the force of 40 newtons is acting. Okay. So, this distance is how much from here? It's 1.2 meters. Also, apart from this, this is not toward the center. You can see the pivot is not toward the center. It's not exactly on the center. So, I'm supposed to consider over here, they have given the mass of the uniform bar also, which is 30 newtons. Now, that force will be acting from the center of mass. This distance is 1.4. What is the half of that distance? This distance is going to be 0.7. From the pivot, this distance is how much?
0.50.
It will be 0.5 meters. Okay. So through the pivot, there are two forces acting. One is of course because of this 40 newtons, and second one is because of the center of mass of the iron bar. So there are two clockwise forces acting. One is because of this 40 newtons, which is going to be 40 multiplied by here the distance from the pivot is 1.2 meters plus the force that is acting due to the center of mass of the iron bar, because the pivot is not in the center. So that is going to be 30 multiplied by what is the distance from the axis of rotation? It is 0.5. So you can just multiply this. This is going to become 48 plus this is going to become 15. So this, if you add both, is going to become 63 Newton meter. Okay, because it's the product of force multiplied by distance. Force will be having unit newtons, meters will be the unit of distance. So Newton meter is going to be the unit of moment of force.